Okay, I'm ready to start a new series. I'm going to start this series off on the moon because that's where I left off with the Jordan Peterson series, and I'm going to try to get through a few things. The person I chose to start the new series is this, looks like a kid to me. His name is Lex Friedman, and I was turned on to him by the Jordan Peterson series and saw him doing some interviews with some very interesting people, some people that are totally full of shit and back and forth with it. People that you might think are full of shit are actually the ones that I like, and then the ones that you might like and think that they're everything are the ones that I see as being full of shit. Um, Before I get into it, these moon photos, I'm trying to explain to anyone that comes to my channel. If you download the moon photographs, this is gonna help while we're looking at some things. And everyone should go look for themselves instead of taking the word of myself or anybody else for that matter. So a couple weeks ago when I started doing this, I downloaded about 20 photographs of the moon. And what I wanted to point out before I delete them is that these 5 that I have right here are all bad for different reasons. This one here has these big square pixels in it. I've already used it actually to make a video for the Jordan Peterson series, um, but it's not going to be clear to anybody coming to this that's new coming to this. So that's why I'm saying download 20 of them. And then this one here was the one that had the wording in it. So I'm probably going to get a copyright strike on that one anyway, and I'll probably have to get rid of it. But the moon photo is good, so it's good to look at, but it's not good to make videos with. This one here is so small and also has Photoshop shit going in on it. Let's start that over again. This is the one with the large pixels. This is the one with the wording in it for a copyright strike. This is the one that's so small that when you blow it up you can see the Photoshop. I don't know why they would do that, I don't know. But they Photoshop it inside of a black screen so that when you enlarge it you can easily see all the Photoshopping shit that went on. And I don't know why, it's just Photoshopped into a night sky and I didn't spend much time looking at it. This one here had computer generated changes. There were changes in the imagery. Fucking thing, man. Camera. This one here has CGI shit. So photoshopping, CGI, and this one also, I believe, had the photoshopping. It had like zigzags around in the night sky, and you could tell that they just placed it on there. So I'm going to delete those, and I'm going to open up a couple of other things before I start this series. Alright, so I did 3 moon videos, and I'm trying to track the what I'm calling timelines of the moon. And the guy that I'm about to play right now, who what's his name? Lex. Lex is about to do an interview with somebody. So now I'm going to blow up this moon photo here, but down here I also have those videos. So let's do this. I'll do this one first. My computer's very slow. Let's see if it fucking blows up. Come on. Is that the one I want? Yes, that's the one I want. And I'll show you why I want that one in a second. As soon as I can blow it up. Because what I'm going to be doing here is I'm going to be taking 3 moons, all two are with a, I got one printed on paper, and I want to just mention that I'm not really in the mood to talk. I'm not in the mood to do videos. I just got to get through this. And I don't have to do a lot of talking anyways, because it's the start of the series anyway. And then I'm going to pop this open at the same time. Give me a second. I should just put this on pause. Here it comes. Okay. So, what, I never signed out? No. Okay, so these 3 moon videos right here. These last 3 moon videos, it's amazing how little anybody's even looking at any of this shit. I watched all these videos 10, 15 times, which means that they're getting 3 to 5 views or something like that, you know. It's fucking amazing, man. Anyways, these 3 here, we're going to be looking at the moon's crescent, shadow, if you want to call it that, to line up these timelines that I'm looking for. And when we listen to this guy that Lex is interviewing, he's almost there. He's almost on it. Kind of the same thing I was saying about Jordan Peterson. They're like just like inches away from seeing it all. You know, you wonder what if I. Then Lex also, I'm gonna do probably not till next week, but I'll do another one as part of his series. Okay, these are taken with my own telescope. First of all, okay, these are my telescope, my moons. I wanted to do that for this reason. I'll just show you what I got going on here too. While I'm at it. Okay, so on that computer, I'm gonna have moon photo, the one I just chose. I got my cropping tools set up over here, so I'm gonna use that on the computer. I'm saying it all now, so I don't have to say it over the next 5 to 10 videos, because that's the next 5 to 10 videos is going to be all about what I'm doing here. Over here, I've got a printout of the moon that I printed out from the computer, which is much better. Why? Because of the pixels, the square pixels. Square pixels that the computer uses are going to be deceiving to people. So, you know, they're going to fuck you up. They're going to make you start believing in your imagination again, and rather than believing what you can see with your own eyes. By printing them, you still have square pixels, because the printer uses square pixels as well, but they're smaller, tighter pixels, especially when you have a full-size photo. If you're going to be blowing up images of the moon, like that other one that I had, then that's going to be a different story. I also have a cropping tool here. I have a light here, an adjustable light, because lights and shadows, whatever way I want to set my light coming over this moon photograph, which I've done a lot of these videos. I mean, I got a couple thousand videos up of doing this in the past. And one of the amazing things that I'll mention is it's on paper. There's no height to the print, right? So when the light comes over this paper and over the shadows, you're going to see how the lights and shadows work to show you different images more clearly. Okay, so like I'll do, this is the one that I was doing last week, if I got my pointer. Right here, I'm going to go in on a whole bunch of them. I'm looking for one in particular, one that I was just on last week. And I'll show you what, if I change my color, see? So I'm changing it up for you. Lights and shadows, lights and shadows. So different colors of lights, just like I was saying about when I'm saying angles of perspective, right? When I'm talking about angles of perspective, then you know I should be saying and adding distances. I should be saying angles and distance of perspective also as well, because that also plays a part. So, you know, here's another example right here of the feminine one I was telling you about. Now another way I can do this too is drag it to the end of the table so I can get my camera down on it better. Just watch out for glare coming in and that kind of thing. But I was over here in my light. I'll flip the camera over in a second, because this camera is actually upside down right now. Hopefully it comes out okay. But she's right here anyways. I'll get into her a little bit more, but the eye, nose, and mouth, and her hair is up here. She's got hair flowing back this way. Her arms coming back this way. She's coming down here, and she's holding her tail. You get a little bit of her waistline, a tiny little bit of a leg at the right angle, and she's got two sets of titties. This don't look like a cone set of titties in this angle, but you can see her little mosquito bite boobies right here. So I'll get in on all these a little bit better as I'm going along. Now I'm noticing when I'm doing the videos that there's all this other imagery going on in the background that might catch an angle. Like for example, this large one, eye, nose, and mouth down here. Canine, there's a big large canine. But it's also changes up too, because you can see a hairdo up here, right? Yeah. So see how I'm going to change my angles of perspective, and then again, while staying on that one, I'll do this color change. I'm doing this during the daytime, and I got a lot of light coming in from my windows and stuff, so it's really not a good idea to do, but I just want to get through it all. So now what I'm going to be doing now, like I said, I'm going to, over the next 5 videos, 10 videos, I don't know how I'm going to do it, see whatever happens. I'd like to get the go through the paper on paper first, and then go back over to these. So let's see, so I'm going to shut this one down to here, and this one I'm going to bring up to this size. Make sure I got the right photograph of the moon that I want. Computer's fucking slow as hell. There we go. Alright, so there we go. Yep. And I usually would take that other monitor back here, and I would lay it down on the table here and do all that, but I'm kind of doing that with this anyway, by having the moon printed on paper. Now, under the Harold Cott series, I got a lot of shit from several people, but mostly from Wolfus. But I'm glad he did, because it took me to a whole new level on many other things. One of them, finding these timelines that I'm talking about. When I found the timelines, which if you want to see the timelines, you can see them very easily. Here, do this. Okay, so I'll just point out a few of them. So here's one right here, right? They're all over the place, right? You have small ones that go all the way through to the other side, and then you have some that are short, and then you have ones that go, like I said, all the way through. Here's one that starts here. They all seem to start at the Sea of Tranquility as well. Is another thing. I gotta pull this back a little bit. There we go. All right, so starting at the Sea of Tranquility, this little dot right here, this little circle right here, starts a lot of them that go all the way through. Those ones all go all the way through. So what I'm going to be looking for over the next few days, number one, do the shadows fall on these lines as the moon's coming through the sky? In other words, like this. Right? So is the moon coming through our sky? The false creators clock the moon, showing us it goes like this, goes like this. So the other night we had a moon that was right here. It's right here. I got the videos of it. One night it was there. So in other words, that's what I'm looking for today. And I still don't even know. I haven't really looked at it yet much. But okay, so this line right here. There's a line coming down this way. Yep, right here. You can see it when I look over the camera. Then there's the next one right here. So this was one night that I have already on film, and then the next line is the next one I have on film. So I'm gonna have to go through the next couple months, 2-3 months it might take me to do it, and I'm gonna, because I have to do it with my own moon videos. I can't trust anybody. Everybody's a bunch of fucking liars. So whether they're purposeful liars or not, it doesn't even fucking matter. They're just all liars. So what am I gonna do? Can't take anybody's videos or photos for granted, or, for their word or nothing. So we're going to check these lines every time the moon comes through. These smaller lines that appear to stop short. Is that because because the moon goes around our sky in a clockwise rotation? We wouldn't know that because we don't we believe in outer space and science and medicine and all that kind of stuff. So we're not even gonna, you're not even gonna understand a lot of this shit until people go and look for themselves. So I want to know about the shorter lines that appear to me to be stopping, but maybe they don't. Maybe they're all coming from this circle right here that we call the Sea of Tranquility. As a matter of fact, this one does continue through. This one does. And there are a lot of these lines. There are thousands of them. So I'm going to have to really get into, I'm only going to do some of this. I'm not doing all of it. Other people have to come into it. So there's one line right here, for example, that has a hook in it. It goes like this, and it comes back and hooks right here. That's one I want to know about. You know? Let's see. Yep, right here. So it comes up and it hooks. It's not this line, because see, this line comes from the circle, comes all the way up, and goes all the way up. And then till we can't see it anymore. So most of these lines, these timelines, I'm calling them, go all the way through to the other side. And as the moon shadows like this, right, as it comes through and as the moon's shadowing in a crescent shape, it's cutting off and cropping exact images perfectly. So that's gotta mean something, you know? Alright, hold on a second. Okay, I think this is gonna be like part 1 or something of the series, maybe part 1, part 2, part 3, or something like that. Then I'm gonna add those other 3 moon videos that I just did to the series. The series will probably take me a couple months to do anyway. It usually takes me a couple months to do a series. So I will, I'll have the answers to this timeline thing by the end of that. At least I'll know what direction I'm going in with it and how correct it feels. Very correct. It feels right. It feels good. So I think it's going to be all right. But just say hi to Lex. I know you don't know me. I'm a nobody. But you're not. You have a very successful podcast. You seem to want to know the answers to everything just like I do. And I have a lot that I'm going to share with you. I hope you'll go look. Go look for yourself. Don't take my word on it.
The following is a conversation with Andrew Huberman, his second time on the podcast. He's a neuroscientist at Stanford, a world-class researcher and educator, and now he has a new podcast on YouTube and all the usual places called Huberman Lab that I can't recommend highly enough. Quick mention of our sponsors: Masterclass online courses, Four Sigmatic Mushroom Coffee, Magic Spoon Low Carb Cereal, and BetterHelp Online Therapy. Click the sponsor links to get a discount. By the way, Masterclass is testing to see if they want to support this podcast long term, so if you're on the fence, now is the time to sign up. And I'm pretty sure Andrew will have a neuroscience masterclass on there soon enough, though his podcast is basically a weekly masterclass in itself. As a side note, let me say that Andrew is a friend and a new collaborator. We're working on a paper together about a topic we're both really passionate about, at the intersection of neuroscience and machine learning. But that's probably many months away from being published. Still, I'm really excited about this work. He's one of the smartest and kindest people I have the pleasure of talking to on this podcast, so I hope we'll talk many more times in the future. If you enjoy this thing, subscribe on YouTube, review it on Apple Podcast, follow on Spotify, support it on Patreon, or connect with me on Twitter at Lex Friedman. And now, here's my conversation with Andrew Huberman. Why do humans need sleep? Let's go with a big first question.
Okay, well, the answer I'll start with is the one that I always default to when there's a why question, which is I wasn't consulted at the design phase. So so I wriggle my way out of giving a absolute answer, right? But there's one mechanism that's very clear, that's super important, which is that the longer we are awake, the more adenosine accumulates in our brain. And adenosine binds to adenosine receptors, no surprise there, and it creates the feeling of sleepiness, independent of time of day or night. So there are two mechanisms. One is we get sleepy as adenosine accumulates. The longer we've been awake, the more adenosine is accumulated in our system. But how sleepy we get for a given amount of adenosine depends on where we are in this so-called circadian cycle. And the circadian cycle is just this very, very well-conserved oscillation. It's a temperature oscillation where you go from a low point. Typically, if you're awake during the day and you're asleep at night, your lowest temperature point will be like 3 a.m., 4 a.m., and then your temperature will start to creep up as you wake up in the morning, and then it'll peak in the late afternoon, and then it'll start to drop again toward the evening, and then you get sleep again. That oscillation in temperature takes 24 hours. Plus or minus temperature. Yeah, plus or minus an hour. And I don't, even though I wasn't consulted at the design phase, I do not think it's a coincidence that it's aligned to the 24-hour spin of the Earth on its axis, and the fact that we tend to be bathed in sunlight for a portion of that spin and in darkness for the other portion of that spin. So there are two mechanisms, the adenosine accumulation and the circadian time point that we happen to be at. And those converge to create a sense of sleepiness or wakefulness. The simple way to reveal these two mechanisms, to uncouple them, is stay up for 24 hours, and you will find that even though you've been, let's say you stay up midnight, 2 a.m., 3 a.m., provided you're on a regular schedule, like that I follow, not like the kind that you follow, I will get very sleepy around 3, 4 a.m., but then around 5 or 6 or 7 a.m., which is my normal wake-up time, I'll start to feel more alert, even though adenosine has been accumulating further. So adenosine is higher for me the longer I stay up, and yet I feel more alert than I did a few hours ago. And that's because these are two interacting forces. So adenosine makes you sleepy, and then just how sleepy or how awake you feel also depends on where you are in this temperature oscillation that takes 24 hours.
Okay, so that's fascinating. So there's a bunch of oscillations going on, and then they kind of, through the evolutionary process, have evolved to all be aligned somewhat, and they interplay. So it's, you said your body temperature goes up and down. Mm-hmm. There's chemicals in your brain that oscillate, and then there's the actual oscillation of the sun in the sky. So all of that together has some impact on each other, and somehow that all results in us wanting to go to sleep every night.
Right. So, and we can get right into the meat of this. So I guess we just dove right in. But the temperature oscillation is the effector of the circadian clock. So every cell in our body has a 24-hour rhythm that's dictated by genes like clock, purr, BMAL. This is one of the great successes of biology. They give a Nobel Prize to Reppert, and I don't know if Reppert got it, forgive me, but sorry if you got it, Steve. Congratulations. If you didn't, I'm sorry, I wasn't on the committee. Nonetheless, did beautiful work, Steve Reppert and others. But Mike Roshbosh and like other people worked out these mechanisms in flies and bacteria and mammals. There are these genes that create 24-hour oscillations in gene expression, et cetera, in every cell of our body. But what aligns those is a signal from the master circadian clock, which sits right above the roof of the mouth, called the suprachiasmatic nucleus. And that clock synchronizes all the clocks of the body to this general temperature rhythm by way of controlling systemic temperature, which makes perfect sense. If you want to create a general oscillation in all the tissues and organs of the body, use temperature. And so that work on temperature, if people want to explore it further, was Joe Takahashi, who was at Northwestern, now at UT Southwestern in Dallas. And it is absolutely clear that humans do better on a diurnal schedule, sorry Lex, than a nocturnal schedule. Because you could say, well, provided I sleep and push adenosine back downhill, which is what happens when we sleep, adenosine is then reduced, and provided I am on more or less a 24-hour schedule, why should it matter that I'm awake when the sun's out and I'm asleep when the sun is down? But it turns out that if you look at health metrics, people that are strictly nocturnal do far worse on immune function, on metabolic function, etc., than people who are diurnal, who are awake during the daytime. And animals that are nocturnal, it's the opposite. And animals that are so-called crepuscular, which tend to be active at dawn and at dusk, This is a beautiful system. I won't go down that rabbit hole, but these are animals whose visual systems operate best. They tend to be predators like mountain lions. They have optimized their waking times for the times when the animals they eat can't see well in those light conditions. But given the rod cone ratios in their eyes, the mountain lion is picking up. It's like when you see special forces and they're looking through night vision goggles and they have a clear advantage, right? They're seeing in the dark. That's basically what it's like to be a mountain lion as opposed to a bunny rabbit.
Would you say that a lot of these cycles evolved in the predator-prey relationships of the different throughout the food chain? So it's basically all somehow has to do with survival in this complicated web of predators and prey?
Almost certainly. There had to have been a time in which humans being awake and active at night as opposed to during the day led to higher levels of lethality, and probably particular in kids. You imagine kids running around in the dark and getting where there are a lot of animals that can see really well under those conditions, and humans can't. And this would be all pre-electricity. Even if you're carrying a torch, I mean, the range of illumination on a torch is nothing compared to what a nighttime predator like a large cat or something can do. I mean, they can see everything they need to in order to eat us, and not the other way around.
So one fascinating thing you said is that blew my mind, and we went right past it, which is that temperature is a really powerful. Like, if you were to think about the ways that different parts of the body, different systems in the body would communicate with each other, temperature would be a really good one. And that just, I mean, maybe it's obvious, but it kind of blew my mind just now that, yeah, these systems are all distributed.
Right.
And they have to they're not actually sending signals, but they're coordinating. They need some sort of universal thing to look at in order to coordinate. And temperature is a nice one to build around. And that way you could control the behavior of all these different systems by controlling the temperature.
Right. It's attractive to think of a mechanism where this master circadian clock secretes a peptide or something that goes and locks to receptors in all the cells and gets it just right. But that leaves far too much room for variability, binding affinities. Cells in a lot of parts of our body are at different stages of maturation. They're turning over, liver cells and so forth. And for instance, we have a clock in our gut and in our liver, such that if we were to just take out your liver and put it on a table and just look at the expression of these genes, it would be in a 24-hour oscillation on its own. It's independent. But something has to entrain them and keep them all synchronized. And so it's not obvious that it would be temperature. Takahashi's great gift to biology was to show that all the stuff coming out of this master circadian clock, at the end of the day, that's a weird statement, no pun intended. At the end of the day and the night, at the end of the story, it all boils down to making sure that the temperature of tissues oscillates in the same fashion.
It's blowing my mind thinking like what other mechanism could possibly exist to create that kind of oscillation.
Well, you're Russian. It's cold in Russia for a lot of the year. The hibernation signal in certain animals is a remarkable signal. There are peptides secreted from this very same clock that in animals like ground squirrels or bears, they go into a kind of a torpor where everything, reproduction, metabolism, everything is reduced while they're in their cave. They don't actually stay asleep all of winter. That's a myth. And they actually do these very dramatic and periodic arousals from hibernation where they just shake and shake and shake. It looks like a seizure, and then they go back under into the torpor. That's from a peptide that's released. But that's different because that's about shutting down the whole system. It's clear that having these very regular oscillations every 24 hours is essential for everything from metabolism to reproduction.
Is there an optimal temperature for sleep that I should mention? I think your latest episode, and people should go check out helixsleep.com/Huberman to support Andrew.
Thanks for the plug.
I mean, the amazing thing about the stuff that you're creating, and yes, you have a new podcast. That's amazing. And this past month, he did a whole series on sleep, which people should definitely check out. There's some podcasts that come out that just make me want to be a better human being by just the quality. 3 Blue 1 Brown, Grant Sanderson is like that for me. Just like, wow, this is education is best. So Andrew symbolizes that and captures that brilliantly. So go support the sponsor so he doesn't stop doing the thing. So I think they have a cooling pad too. So the 8 Sleep mattress sponsors me. They send me a mattress, and I've never, listen, I used to sleep on the floor.
Sleep where you fall.
Sleep where I fall. Yeah. I don't give a shit. It doesn't really matter. But so like I would have never bought a nice mattress because it's like, why? I'm fine. This is the floor. It's fine. But it was a game changer to be able to control temperature. Like for me, it's cooling. Mm-hmm. To cool, I don't know what the hell it is.
Well, you want the brain and nervous system and the rest of the body needs to drop by about anywhere from 2 to 3 degrees in order to get into your deepest sleep and transition to sleep. That's really going to help. You don't want to be cold that you're bothered and can't fall asleep, but that's why some people like it really cold in the room and under a warm blanket or with socks on. For some people that can be good, because this temperature oscillation is such that as your temperature is dropping, that correlates with generally with the most sleepy phase of your circadian cycle. So cool is better for falling and staying asleep and sleeping deeply.
And then I guess like that's what 8 Sleep showed. They have like an app. It warms back up to wake you up. The idea that I haven't actually used it. I'm like, this is stupid. People say it works, but just keep it the same temperature throughout the night. But warming it up, I guess, wakes you up, which is fascinating.
Yeah, because the wake up signal it's interesting to think about. It's not just correlated with an increase in body temperature. The increase in body temperature is triggering the release of cortisol from your adrenals, and that's the wake up signal.
Do you think it's absolute temperatures we're talking about, or is it just even relative? Just the decrease?
Well, everyone's going to have slightly different basal temperature. The idea that everybody should be 98.6, I mean, that's a myth. And there are theories that body temperature overall has been dropping in the last 50 years or so. I doubt that's true for somebody who is athletic like you and is young and healthy. But basically, the coldest period of that 24-hour cycle is when you are going to be sleepiest. There's actually a period within that 24-hour cycle. It's a time point called your temperature minimum, and your temperature minimum tends to be about 2 hours before your typical wake-up time. I'm not talking about the wake-up time in the middle of the night where you go use the bathroom or where you set an alarm to go catch a flight. I mean, if you were to just allow yourself to sleep without a clock for a few days, measure when you typically wake up. 2 hours before then is your temperature minimum. And that temperature minimum turns out to be a very important landmark in your circadian cycle, because it turns out that if you get bright light in your eyes in the hours immediately before your temperature minimum, so 2 to 4 hours, or any time within the 2 or 4 hour window before that temperature minimum, you are going to what's called delay your circadian clock. The next day, that whole oscillation is going to move forward. It'll make you want to go to sleep later and wake up later. Whereas if you get bright light in your eyes in the hours after that temperature minimum, so let's say for me, typical wake up time is 6 a.m. My temperature minimum is somewhere around 4 a.m. If I get bright light in my eyes 5 a.m., 6 a.m., 7 a.m., it's going to advance that oscillation so that I'll want to go to bed earlier and wake up earlier the subsequent nights. So you might say, wait, but most nights I go to sleep and wake up at more or less the same time. Why is that? And that's because the same thing is happening on both sides. You are both advancing your clock a little bit and assuming that you're looking at light in the evening, you're also delaying your clock a little bit. So you get kind of captured in between, and then your rhythm more or less oscillates at the same period, as we say, as the spin of the earth. Unless you're like you, where I get text messages from you sometimes at odd hours, and if you're on the East Coast, then I know that you had to have been pulling basically an all-night.
Yeah. That's the interesting point about the messiness of sleep. So most people seem to perform the best when they have like a regular sleep schedule. I perhaps am the same, but I don't know that. And I tend to believe that you can also perform relatively optimally with chaos of sleep. Of like a weird soup of like power naps and all-nighters and all of that, as long as you're like happy, doing what you love.
What do you want?
And maybe you can tell me what you think about this.
What? No, the cat's still outside. You can yell for her while you're out there.
Diet with sleep is that if I obsess about it being perfect, then I'll actually stress quite a bit when it's not. Like, I'll feel shitty when I don't get enough sleep because I know I should be getting more sleep as opposed to the actual physiological effects of not getting enough sleep. I find if I just accept whatever the hell happens, happens and smile and just, take it all in, like David Goggins style, like if it sucks, it's even better. Or what is it, Jocko's like good or whatever he says.
Right. I think there are several things that you said that are important, but I agree that one can have a dysregulated sleep schedule and still be a happy person and productive. I mean, much of my life I've pulled all-nighters and slept weird schedules. I think many people can probably relate to going to sleep, waking up 4 hours later, being up for an hour or two on your computer, then going back to sleep and getting amazing sleep the next day functioning. I think it's important that people have highlighted the importance of sleep and getting enough rest. I do think it's gone too far, and now I'm editorializing a little bit, but I think that we've created this anxiety about sleep that if we don't sleep enough, we're going to get dementia. If we don't get sleep, then the reproductive axis is going to completely crash. There's a lot of evidence to the contrary, and as well, just based on personal experience and based on the fact that, sure, that it may be that a solid 8 hours with no interruptions in there, or 9 or 10, could do great benefit, but you can do really well if you do what you say, which is you wake up, you don't want to start stressing about it, creating this meta stress about sleep. Being happy is actually one of the most powerful things that you can do, not allowing yourself to go down that rabbit hole of stress for the following reason. A lot of our fatigue is not due just to the buildup of adenosine or time of day, the circadian thing we were talking about earlier. An additional factor is that effort is related to the release of epinephrine, of adrenaline in our brain and body. At some point, those levels get so high that we get stressed mentally, we get stressed physically, and we want to give up. There are good data published in Cell showing that signal, the epinephrine signal, eventually accumulates and there's a quit point. Dopamine, the molecule of pursuit and reward and feeling good, resets our ability to be in effort. In fact, a lot of people don't know this, but dopamine is actually what epinephrine is made from. If you look at the biochemical cascade, it starts with tyrosine, which is rich in found in red meats and things of that sort. And tyrosine is eventually converted through things like L-dopa into dopamine. Dopamine is made into epinephrine. So, I mean, this sounds kind of new agey, but happiness, joy, and pleasure in what you're doing creates a chemical milieu that provides more of the chemicals that allow for effort. And there's nothing new agey about that. It's in every biochemistry textbook. It's in every decent neuroscience textbook. They just don't talk about the happiness part. They just talk about the dopamine part. So I think that limiting your stress and at least recognizing, okay, if you're pulling an all-nighter or you're somehow on messed up sleep,
so in other words,
there is going to be a point in that 24-hour cycle where your brain is not trustworthy, where your mental state is not worth placing too much weight on because you are near that temperature minimum. And near that temperature minimum, which correlates to that about 2 hours before you would normally wake up, the brain is hobbling along. And anything you feel or think at that time should not be given too much value. But if you can trick yourself into thinking that's the pleasure point, you afford yourself a huge advantage. There's a study done by a colleague of mine at Stanford that showed that positive anticipation about the next day events actually is a powerful metric for creating quality sleep, even if the sleep is very reduced. And you'll love this one, and I a lot of people are going to, might be critical of this, so I just want to make sure that, so this was work done out of Harvard Medical. It was Bob Stickgold's lab, and Emily Hoagland did this study that showed, looking at OChem, performance on OChem scores. Okay, so organic chemistry at Harvard is a pretty tough subject, highly motivated, a number of very good control groups in this study.
what she showed was that consistency of total sleep duration was far more important for performance on these exams than total sleep duration itself. So it's not that just getting more sleep allows you to perform better. Consistently getting about the same amount of sleep is better for performance, at least on OCHEM, than just getting more.
That's interesting. So that's referring to more that there should be a consistent habit versus the total amount. To me, like the entirety of the picture of sleep is similar to nutrition in that it feels like there's so many variables involved and it's so person specific. So, a lot of studies, I mean, this is the way of science, has to look in aggregate the effects on sleep. It doesn't focus on high performers, which are individuals ultimately.
So I'm just going to mention real quick, my light is over to my
so
right.
It's a very important question. It's like, what kind of diet
if I move
fights
the light
obesity,
over to the left or over here
reduces
or
obesity?
any other
It's
angles,
another question.
it's
What kind of diet
perception
allows David
of the
Goggins to
lights
be the
and
best
shadows.
version
The
of
lights will
himself?
be
So
coming over
these
in a
high
different
performers in
direction.
different avenues.
Amazing
And the same
that
thing
it's
with
only
sleep.
lines on a paper.
People that
That's
tell
all it
me
takes.
that I should get 8 hours of sleep, it's like I get it, and they may be right, but they may be very wrong.
So
there's no evidence that 8 is better than 6. That you could very well do better on 6 than on 8. There are a few other things that turn out to be strong parameters for success in this domain. For instance, your entire life, waking or asleep, is broken up into these 90-minute ultradian cycles. If you look at ability to attend or do math problems or do anything, drive, your performance tends to ramp up slowly within a 90-minute cycle, peak, and then come down at the end of that 90-minute cycle. And in sleep, we go through these stage 1, 2, 3, 4, REM, etc. We'll talk more about that if you like. Those on 90-minute ultradian cycles as well. Ending your sleep after a 90-minute cycle, at the near the end of a 90-minute cycle, say at the end of 6 hours, in many cases is better for you than sleeping an additional hour, 7 hours, and waking up in the middle of an ultradian cycle. And there are a few apps that can measure this based on body movements and things like that, that have your alarm go off at the end of an ultradian cycle. And if you wake up in the middle of an ultradian cycle, sometimes, not always, you can be very groggy for a long period of time. I certainly do better on 6 hours than I do on 7. I happen to like an 8-hour sleep. It feels great. But I haven't slept an entire 8 hours without waking up in the middle of the night at some point in, I don't know, forever. I can't remember. It's probably some point in infancy. And I function well during the day. I think that's an important parameter, is how do you feel during the day? Almost everybody experiences some sort of dip in energy in the late afternoon, or what would correlate to their temperature peak. And that's a good time of day to get either a 90-minute or less nap, or if you're not a napper or you can't nap, feet elevated has been shown to be good for clear out of some of this. The glymphatic system is this kind of like sewer system of the brain that you can clear stuff out. So legs elevated, or one thing that I'm a big proponent of and that my lab has been studying is what I now call NSDR, non-sleep deep rest. And this is just lying down. There are some scripts that we're going to put out there soon as a free resource. There's some hypnosis scripts that my colleague David Spiegel has put out there as a free resource. But non-sleep deep rest is allowing your system to drop into states of real calm that allow you to get better at falling asleep later. And they can be very restorative for cognitive and motor function. There's at least one study out of Denmark that shows that the basal ganglia, which is an area of the brain that's involved in motor planning and action, one of these 20-minute non-sleep deep rest protocols resets levels of neuromodulators like dopamine in the basal ganglia to the same levels that they were right after a long night's sleep. So I also respectfully or semi-respectfully disagree with the idea that you can't recover lost sleep. What does that mean? I mean, that there's no IRS for sleep. So what does it mean to be in debt for sleep? If you're falling asleep during the day and you're sleepy, like you're falling asleep, that's a good sign of insomnia. It means you're not sleeping enough at night. If you're fatigued during the day, but you're not falling asleep, so you're just exhausted, but you're not finding yourself falling asleep in meetings and in conversation, then chances are you're fatiguing your system through something else, like a long run in the middle of the night in
Yeah,
Boston or
yeah.
whatever it is that you're up to lately at 3 a.m.
Yes, there is a magic to the nap, and I mean, maybe you could speak to because you mentioned these protocols that don't necessarily, so they're non-sleep, but to me, the nap, one or two a day, can almost irrespective of how much sleep I get the night before, have a fundamental change in my mood and my performance.
For the
and all
better
those
or for
kinds
the
of- for the
worse?
better, for the better.
Yeah, likewise.
So I do tend to kind of experiment with durations. It's consistently surprising to me how like a nap of like 10 minutes